Hello. This video summarizes steps I took to change the speed of my Lortone rotary rock tumbler. This is definitely a your mileage may vary video, and if you decide to do something similar, please exercise appropriate electrical cautions. I recently, within the past 6 months or so, purchased a Lortone Model 3A, which uses an AC motor. It has a 3-pound barrel, and it does not have a speed control. With the barrel 3/4 loaded, I found that it was tumbling at about 65 RPM, which may not be ideal. If sufficient media is not used, the rocks might bruise. So, how to slow it down? The other tumbler you see is a Highland Park model that uses a DC motor and has a DC drive, and which has an adjustable speed control, which I have set at 45 RPM. And there's the tumbler. So, I thought about doing a mechanical change with the Lortone by changing pulley diameter or somehow increasing the barrel diameter, but I chose to go the electrical route. There are a lot of AC quote-unquote variable speed devices available, but I got the feeling that they might only reduce the voltage, and that could be bad. I checked with Lortone, and they indicated that the motor is quote-unquote induction shaded pole. To my knowledge, lowering only the voltage on such a motor would slow the speed, but it would also lower the motor torque and increase the operating current, with a corresponding increase in operation temperature, with the risk of possibly overheating and failure, or at least reduced life of the motor. So, with my background of electrical engineering, I thought a better solution for the induction motor could be a VFD, that's variable frequency drive. It might proportionally reduce the frequency and the voltage towards maintaining torque for the lower than rated motor speed. I've worked in the electrical power industry and have routinely seen VFDs for much larger motors, for example hundreds of horsepower, whereas the Lortone motor is only rated for 36 watts at 115 volts AC, so it is much less than 1 horsepower. Here's the nameplate. There you go. Okay. After a lot of research, I found 2 videos that discussed low wattage rating VFDs, and they also provided guidance on using them. I took a chance and ordered one for about $40. Here's the model number. And I'll also show you the front page of the manual that came with it. They have XXX for the watt rating. It's a T13 750 watt 12H. The specs for this VFD show the input as single phase AC 220 volts plus or minus 20%, and it also produces a 220 volt 3-phase output. But one of the videos said they applied only 110 volts to the input, but they got 110 volts at the output. Bonus. A second video helped with understanding the VFD manuals that come with these small VFDs. I gleaned from that video to change the default 50 Hz settings to 60 Hz based on my US house voltage. I then bought a 16 gauge 3-wire extension cord, and I'll show you that a little bit. And I cut it so it could be wired to the VFD single phase input, and with the receptacle part of the cord wired to the VFD output. I only used 2 of the 3 output terminals because it's a single phase AC motor in the Lortone. I have successfully energized the VFD and ran the motor and I'm now able to reduce the speed. I'll show you that in a moment. I also ended up changing one of the other default VFD settings, specifically the quote-unquote linear voltage ratio, because with my supply voltage of about 124 volts at 60 hertz, the VFD output was around 131 volts at 60 hertz. So by changing that default, the VFD output is now about 124 volts with the input at 124 volts for 60 hertz. So now I can dial down the output to about 44 hertz with the corresponding voltage at approximately being about 107 volts, and the tumble speed will be about 45 RPM. I'll show you how that works. First I turn on the power to Lortone. It's not going on yet because I haven't turned on the VFD. I'll turn on my voltmeter here so you can see. And now I'm going to hit the start button. Okay. That's showing 44.2 hertz. And my voltmeter is a little bit bad, but it's 162 volts. And there's the speed. So that's the 45 RPM approximately. I'll pan out and I'll ramp it up to 60. Voltage goes up 123 something. Much faster. This would be how it would be normally operating. So I'm going to dial that back down. And it's all beautiful. So what you have seen is my quick electrical connections, as you can see. I need to secure the input-output cord connections and look into a suitable enclosure for the VFD. This VFD has an internal cooling fan, which you can kind of see here on the side. You can kind of hear a little bit. It makes a little noise, but not too much. About the same as the tumblers. The VFD also has a number of interesting control monitoring points. I don't use any of those, so I'm not going to show you any of that. And that manual that you see there is easy to find online if you are at all interested. So, thank you for watching. Cheers.